Assalamu alaikum students, back again. In the last lecture we discussed about the Arrhenius concept of acid. We discussed about the Arrhenius concept of an acid. Let me recapitulate. According to Arrhenius, acid was a substance that releases or furnishes H positive ions as the only positive ions, and in the other definition we said as any species can be regarded as an acid if it increases the concentration of H positive ions when added to water. So according to Arrhenius, we are going to discuss today what is base. What is a base? According to Arrhenius, what is a base? A base is a substance that releases or furnishes OH negative ions, hydroxide ions, when dissolved in aqueous solution. When dissolved in aqueous solution. Fine. According to Arrhenius, a base is a substance that releases or furnishes OH negative ions, also called as hydroxide ions, when dissolved in aqueous solution. Example? Let us take the example of dissociation of sodium hydroxide. I am writing over here dissociation of sodium hydroxide, that is NaOH. Fine. We are dissolving it in water and we are getting Na positive along with OH negative ions. So we got here OH negative ion. So a base is a substance that releases or furnishes OH negative ion when that substance was added to water. Since NaOH releases OH negative ion, hydroxide ion, we may call it as a base. Clear? Let us move to the second definition of base according to Arrhenius. That is, any species that increases the concentration of OH negative ions when dissolved in water may be called as base. That is, any species that increases the concentration of, that is, the number of OH negative ions present in the water increases. Since we know, as discussed in already, H2O is itself made up of two things. First one being H positive, the proton, and another being the OH negative ion. Fine. Since if we added NaOH to the water, water itself contains H positive and OH negative ions. When we dissolved NaOH into the water, Na positive and OH negative, the OH negative of the water and the OH negative that is being released by the NaOH, the number got increased, it became 2 OH negative. I am repeating over again, H2O is itself made up of H positive and the OH negative ions. H positive is itself made up of H positive and OH negative ions. When NaOH is dissolved in water, what we got is Na positive and OH negative ion. Already OH negative is there, we are adding another OH negative. That means we are increasing the concentration. It was 1 basically, now they are 2. So the number or concentration of OH negative ions got increased when added to water. So according to Arrhenius, any species that increases the concentration of OH negative ions in the water is called as base. I am repeating from the very beginning. According to Arrhenius, a base is a substance that releases or furnishes OH negative ions when that substance is added to water. Let me give you another example of calcium hydroxide over here. Calcium hydroxide gives Ca2 positive and 2 OH negative. Fine. Calcium hydroxide, H2O dissolved in water. What we got is Ca2 positive and 2OH negative. It releases 2OH negative ions. Fine. If any substance is releasing OH negative ions when it is dissolved in water, it is called as a base according to Arrhenius. So we summed up the Arrhenius concept of acid and base. I am going to repeat. According to Arrhenius, acid was a substance that releases or furnishes H positive ions, and a base is a substance that releases or furnishes OH negative ions when dissolved in aqueous solution. Fine. So we are moving to the next concept, that is the classification of acids. Classification of acids. Our next topic will be classification of acids. Classification of acids. How do we classify acids? Fine. Classification, as we all know, means grouping up the same elements having similar characteristics or similar traits or similar properties in one group and separating the other ones that are not similar to those. So classification, what do we mean by classification of an acid? I told you that classification simply means to group the similar elements together. If elements. Now here we are discussing with the compounds, that acids are the compounds. So we have to group the similar compounds into one group, and dissimilar elements are separated, or dissimilar compounds are separated from one another. Now how do we classify acids? We classify acids on the basis of strength, we classify it on the basis of source, we classify acids on the basis of molecular composition, we classify them as on the basis of basicity, and we classify them on the basis of concentration. Fine. So basically acids are classified into 5 groups on the basis of strength. On the basis of strength, acids are of 2 types, first one being the strong acid and the second one being the weak acid. We will discuss separately this thing, what do we mean by strength of an acid. Here I am just making the flow chart of classification of acids. How do we classify the acids? We classify acids on the basis of strength. On the basis of strength, acids are of 2 types, strong acid and the weak acid. We will discuss separately what do we mean by strength of an acid and how do we classify it on the basis of strong acid and weak acid in the next lecture, inshallah Rahman. On the basis of source. On the basis of source, acids are of 2 types, organic acids and inorganic acids. On the basis of basicity, acids are classified into 3 types, monobasic acid, dibasic acid, and third one being the tribasic acid. Tribasic acid. On the basis of concentration, acids are classified furthermore into 2 groups, dilute acid and concentrated acid. And the last one, that is the molecular composition, acids are classified into furthermore 2 types, that is oxyacids, also called as oxoacids, and the hydra acids. Classification of acids. How are acids classified? Depends on what basis you are taking. If we are classifying acids on the basis of strength, there are 2 types, strong acids and the weak acids. If we classify them on the basis of source, there are further 2 types, organic acids, inorganic acids. If we are classifying the acids on the basis of basicity, there are 3 types, monobasic, dibasic and tribasic. If we are classifying it on the basis of concentration, there are furthermore 2 types, dilute acid and the concentrated acid. And if we classify them on the basis of molecular composition, so there will be further 2 types, oxyacids and then the hydra acids. Now we will be discussing separately each one among them, that is the strength, on the basis of strength, on the basis of source, and so on. Let us start by studying classification of acids on the basis of strength. That is, what do we mean by strength of an acid? What is strength of an acid? What do we mean by strength of an acid? So I'm writing over here the first one, strength of acid. What actually strength of an acid is? Strength of an acid means to what extent the dissociation of an acid takes place. By strength we mean to what extent dissociation means breakdown into ions, to what extent dissociation of an acid takes place. It is also called as degree of dissociation, or sometimes it's also called as degree of ionization, and it is represented by a symbol alpha, whose value is equal to number of replaceable H positive ions upon total number of hydrogen atoms present in that acid. I am repeating, what do we mean by strength of an acid? Strength of an acid means to what extent the dissociation of an acid takes place. Dissociation means breakdown into ions. To what extent ions are being formed. It is also called as degree of dissociation, and sometimes it is also called as degree of ionization. And strength or degree of dissociation is represented by a symbol alpha, whose numerically equal to number of replaceable H positive ions present in the acid divided by or upon total number of H atoms, hydrogen atoms. How many hydrogen atoms are there? But it will get cleared on the basis of an example. Example, HCl. We know HCl, if we dissociate it, HCl in water, it will form H positive and Cl negative. Fine. Check the strength, number of replaceable H positive ions. That is, how many H positive ions are there? A single one, upon total number of hydrogen atoms in the formula. Hydrogen atoms only one. So alpha is equal to 1. Since the value of alpha ranges from 0 to 1, 1 being the highest value, that is a strong acid. 1. Since the value of dissociation of HCl is 1, so it will be called as an strong acid. That is, the dissociation is complete. Complete by meaning complete, that is the value of alpha is 1. It ranges from 0 to 1. If it is 1, it's a very strong acid. If it's in between 0 and 1, it's a weak, it may be a weak acid, it may be a strong acid. However, if the value of is decreasing, it is a weak acid. Fine. Moving to another example, that is H2SO4. Sulfuric acid, also called as king of chemicals, H2SO4, gives 2H positive and SO4 2 negative. H2SO4 gives 2H positive and SO4 2 negative. 2H positive. Let's check out the value of alpha. Number of replaceable. How many are being replaced? 2. How many were present? 2 also. 2, 1 or 2. So the value of alpha being equal to 1. The value of alpha being equal to 1 means H2SO4 being a strong acid. Moreover, it will also be cleared on the basis of this example. The example over here is CH3COOH, that is the acetic acid or ethanoic acid. CH3COOH. Fine. Dissociation. It dissociates into CH3CO negative and H positive. Since the number of hydrogens present in the formula is 3 plus 1, 3 over here and the 1 over here. So the number of total H positive ions in the formula is 4, and it is releasing only one H positive ion, releasing only one. They are here, H positives are only 1. Total 3 plus 1, 4. 1 upon 4 becomes 0.25. So it has 1. It is releasing 1. It had 4. So alpha is basically, the value of alpha is less. So it is an weak acid. Now we will be distinguishing between the strong acid and the weak acid, and we will be writing 3 or 4 points of difference between strong acid and weak acid. Let me recapitulate you about the first thing, that H positives are not floating over the surface of water. They are not floating. They combine with the H2O water molecules and result in the formation of H3O positive. So we can say a strong acid has a higher number of hydronium ions and a weak acid has a less number of hydronium ions. Fine, strong acid dissociates completely, they will react with the water molecules, they will form the H3O positive ions. If the number of H3O positive ions are greater, acid is a strong acid. If the value of H3O positive ions is very low, so this will be called as a weak acid. I am writing over here difference between strong acid and the weak acid, and what do we mean by now strong acid and weak acid. Strong acids, over here the weak acids. First one, the acids that dissociate completely, that is they ionize completely, are called as strong acids. The acids that dissociate completely are called as strong acids. The acids that dissociate partially, not fully, like example CH3COH, are called as weak acids, being the first point of difference between them. The acids that dissociate completely are called as strong acids. The acids that dissociate partially are called as weak acids. Point number 2, they have higher value of alpha, that is the degree of association, dissociation or degree of ionization. They have the lesser value of alpha. Fine. Third point, they contain higher number of H3O positive ions. H positive ions combines with the water molecule and form H3O positive ions. So basically the solution of an acid, if it contains higher number of H3O positive ions, it will be called as a strong acid. If it contains lesser number of, they contain lesser number of H3O positive ions, that is hydronium ions. And the fourth point being over here is examples. What are the examples of strong acids? HCl is the best example, H2SO4, fine, H3PO4, phosphoric acid. These are the examples of strong acids. And on the weak acids, we have the examples like that of CH3COOH, acetic acid, and the next one HCOOH, also called as formic acid. Fine, this is acetic acid. So basically we differentiated between strong acids and weak acids, and we got to know about what are strong acids. So what are strong acids? The acids that dissociate completely, that is they ionize completely in the water, their alpha being equal to 1, are called as strong acids, and the acids that dissociate partially, fine, are called as weak acids. There is one more important point about strong acids and weak acids. That is the most important point about strong acids and weak acids. That is, when strong acids dissociate in water, they only produce ions. They only produce ions in the aqueous solution, while as these produce ions as well as molecules in the aqueous solution. I am repeating again. Strength of an acid. Strong acids, when they dissolve in water, they produce only ions. They don't produce molecules in the aqueous solution. While as the weak acids produce ions as well as molecules in the aqueous solution. That is, If the weak acid is dissolved in water, it produces ions in the solution as well as molecules in the solution. While as if we look at the strong acid, there will be only ions and only ions in the aqueous solution. So let me repeat the points of difference between strong acids and weak acids. The first one being the acids that dissociate completely or that ionize completely in the aqueous solution are called as strong acids. The second point difference being they have higher value of alpha. Alpha means degree of association or degree of dissociation. Sorry, degree of dissociation or degree of ionization. They have higher value. That the third one point being they contain higher number of H3O positive ions. And the fourth one being the example. Example is HCl, H2SO4 and H3PO4 of what? Of strong acids. Now looking at the weak acids. The acids that dissociate partially. Those that dissociate partially, that is they do not fully dissociate into ions, are called as weak acids. The second point, they have the lesser value of alpha, means alpha degree of dissociation, they have lesser value, means 0.25, 0.30, 0.40 more. Third point, they contain lesser number of H3O positive ions. And the fourth one, the examples being CH3COH, acetic acid and the formic acid. And the most important point, when the strong acids are dissolved in water, they produce ions only. When weak acids are dissociated into the water, they produce ions as well as molecules. Inshallah Rahman, in the next lecture, we will be discussing the classification of acids on different components, that is on the base of basicity, on the base of molecular composition. In next lecture, Inshallah Rahman. Thank you. Assalamu alaikum wa rahmatullah.